All this is Dr. Mobeen Sayed from drbeen.com. Welcome to one more show. This discussion today, this topic is courtesy of Sky Frog. His question is the following. The question is, how does one variant become dominant? I do not see the mechanism for one variant displacing another. So that is a question, beautiful question, and it is an interesting one as well. So let's have this little diagram in front of us. Quick references. This is drbeen.com. And then here, Sky, this is an interesting article. Although in this article, only one paragraph is really useful. The rest is just a lot of filler material. Good article, not bad. And I have this link in the description too. So now let's very quickly see how a variant becomes dominant. I think there is a equally good question to attach with this, and that is, where do the original variants go? That is like, where do all the lost things go? So let's look at it together. So imagine this is a cell here. On this cell, we have ACE2 receptor. Let's say this is the ACE2 receptor. I deliberately made it a big receptor so we can look at it. In our body, when there are molecules that connect with each other, their connection, of course, depends upon a lot of environmental factors, but some factors, just to get us started, are number one, the shape of the molecules, both molecules. So this would be phenotypical behavior or shape behavior. So if they would fit better, then they have a better chance to attract to each other. One. Secondly, as they are attracted to each other, as they are fitting together, there are chemical forces as well, especially the charge, electromagnetic or electrochemical forces too. And we know that, for example, sodium is positive and chloride is negative and so on. So it is possible that there are amino acids that are positive here and amino acid that is negative here. So that means there is a attraction, there is a force that binds them like magnets together. This could be that there is a negative here and there is a negative here at this point now, and you may say that this area would be repelling each other. So imagine if there is another competing molecule that has one side positive here, that would allow this to be attracted to each other at that point too. That means that molecule that has both positives, positive and negative, and positive and negative here, that has a better affinity to bind compared to a molecule which has negative, negative, and negative and positive. The point is, as the proteins have their shapes, not only the shape matter, but the surface charges on the shape matter as well. And now, if you go back here to this situation, imagine there is a cell here with the ACE2 receptor. That ACE2 receptor can be now bound by, let's say, virus variant A, B, and C. So they're all standing there, they're all present in a large quantity, and they're all trying to bind with this one. What happens is, whichever has higher magnetic force or affinity, that would attach in it be better than others. So because of that, we say that the affinity force is more for a specific variant compared to the other one. So this variant would outcompete the other ones. Now, can the other one outcompete this one? Yes. If, let's say, the variant A is actually weaker in binding with ACE2, however, the variant A has more in quantity, the numbers are more, then that would attach here more than this guy, because this guy would have less chance to get the handout to ACE2 in the crowd that is made up of variant A. But generally, what happens is that when a new variant is formed inside a person, and that variant has a better affinity for the attachment, then that variant starts getting a chance to get attached and get into the cell and make more daughters, and then come out of the cell and then very quickly enter the next cell faster than the other variants. So that is one factor. And for example, Wuhan virus, or the original wild type virus, versus Delta. Delta was actually better in getting attracted to ACE2. So it was better in transmissibility. However, delta was not better than beta or lambda or some other variants as well in attachment force. Its affinity was actually lesser than beta. Then how did beta not win over delta? Because it's not just the affinity, but also the escape from the immune system or the antibodies. So the problem that the virus is trying to solve to become dominant are two. There could be many, but two in this context. And these are, it has to make a change. And again, we are talking in context of the SARS-CoV-2, so I'm going to just stay within that context. So let's say this is a spike. This virus has a problem to solve. The problem to solve is it wants to have more attractive force between its receptor binding domain and the ACE2, which means it wants to make changes to the spike protein. However, when it is making changes, the second problem it has to face and solve is that if the changes are sufficiently large, they may actually make it incapable of attaching with ACE2, but make it easier to escape the antibodies. So, two factors are very important for all the variants now. One, they have to make changes to escape the antibodies, but they have to make changes which are not so drastic that they cannot bind with the ACE2 anymore. And not only they have to make sure that the shape is not so different that they cannot bind, they continue to bind. They also have to make sure that they can bind with more affinity compared to their own competitors, the other daughters. So there is a war happening in the people who are infected. That war is on two fronts from a virus. If we all become a virus for a second, we have two wars to win. On one end, we have to fight with the antibodies. And so we are making changes in us willy nilly to see, can I escape an antibody? So let's say I make a change in myself that I can escape an antibody, but now is that change going to allow me to bind with ACE2? And I have to strike a balance between these two. If I can strike a balance between these two, that I can make decent enough changes that I can push the antibodies away from me while keeping my attraction or even increasing my attraction for ACE2. And if I can improve these two factors over the other ones, then the other viruses would stand there while I connect with this one. Now, these other viruses that are standing there, they are going to be eaten up by the immune system and destroyed. So what I'm trying to do is, I'm still being a virus, SARS-CoV-2. What I'm trying to do is, I'm trying that the other viruses get eaten up and I get to get into the cell. This is like when there's a joke that a few friends were going to a jungle and one of them said, if the lion starts chasing us, what would we do? And the other one said, I just have to run faster than you. Correct. So that is the thing here. This variant just has to be faster than the other variants. That's all. So the other variants will then be picked up by the immune system and destroyed, while this can quickly get into the cell and come out. So where do the other variants go? Where do, for example, the Wuhan variant go? Other than present somewhere in the labs or present maybe some in some communities, majority of that has become eliminated. This is the hope from Omicron as well. If Omicron is more transmissible, that means it can get into the cell faster. That means it would take over the other ones. And if it is less lethal, then it would be a good outcome. But if it is more lethal plus more fast or most transmissible, then we have a problem. Now, this is the SARS-CoV-2 variant discussions. Inside, there are two more factors that are less important for SARS-CoV-2. One factor is that when the virus is inside the cell, how fast can it replicate? If there is a variant that has enzymatic changes that allow the new babies to be formed faster, then that would win. The problem is that because our ribosomes are involved and our cell's machinery is involved, they cannot push our machinery so much that there is a huge difference between various variants. So that one part is not really applicable for SARS-CoV-2. Then a third possibility of better outcome or dominance is when the virus is coming out of the cell. This is true, for example, for HIV virus. When the virus is coming out of the cell, it is kind of in the beginning holding the cell like a lover and does not want to let go, and then slowly coming off of it. And the faster it can be released, or it actually needs a protein to cleave it away from the cell. The faster it can be cleaved, the faster it can go and enter the other cell and start the process. And if it would be slower in being cleaved, then it would hang out here for a longer time. Actually, this is one of the therapy for HIV, that we do not allow it to be removed from the cell. It just tries to get out and get stuck there and cannot go to another cell. So these are the factors too, but for SARS-CoV-2, so far these factors are not heard. For SARS-CoV-2, the two factors that are heard are, number one, the affinity to ACE2, and number two, capability to escape the antibodies. Now, one final beautiful point here. The beta variants were actually more affine than delta for ACE2, but they could not take over. That means it's not the affinity to the ACE2 alone that works, it is also the capability to escape the antibodies. And Delta was more fit because it had a better control over pushing the antibodies away and connecting with the ACE2 better. That means Omicron would have to do something similar to dominate, similar over Delta. And I think it is doing that, and that is why it is dominating. So this is the discussion. Sky, this was a beautiful question. Thank you very much. And I'm going to come back again for another update on the Omicron. Then we would do probably a chit chat as well. So thank you very much. Please like, subscribe, and share. If you would like, there are 3 links in the description. You can buy me a coffee, or you can be a patron, or if you like, you can use PayPal. See you in a few minutes.